acceleration position sensor. Welcome to Kigali-Engineers-College. Especially the session of today, it is about the engine management. We know that the engine, it is used in the many things in order to provide the mechanical motions or mechanical power. So it is the thermo engine. So the engines, the modern engines, it is controlled by the computers, or it is controlled by
So there is the brief on the engine's components. As you see on the figure, there is the main components of the engine that work together in order to provide the final result of providing the torque to the final or to the flywheels to drive the car. So engine, there is the four-stroke cycle. As we see on the figure, there is the inductions, there is the compressions, power and exhaust. It is the four-stroke cycle of the engines that occur in order to provide the power or the torques that push the piston down to rotate the crankshaft. Many systems include in the engine management. There is the ignition system, fuel supply system, air induction systems, actuators, processor, and the sensors. So there is other systems called the exhaust gas recirculation systems, and on the other advanced technology about on the engines, they can add the more systems in order to manage engines and increase its performance.
Or it is controlled by electronics. So there it is the panel that combines the different systems used in the engine management. It is the combination or association of many systems controlled together in order to cause the engine have the more efficient performance or have the more power or torque. So I am going to explain all of these systems and its operations. After we will see how it operates. So as we know, the vehicle, it must have the battery. It is used to store or to convert the chemical reaction into electrical energy. That electrical energy it is used to perform or to make activation of these all systems in order to cause the engine to run or to drive. The management is controlled by this ECU or electronic control module. As we start, there is the battery, there is some cables, there is other components. So the first component of the engine management, there is the battery, because the battery, it is the one which provides the power of electrical to perform or to activate all these systems. So we are going to start with the ignition system. This is the electronic ignition system. Its component is the battery, so control switch, there is their fuse, there is this coil or igniter, so it combines coils and this high tension cable. There is their spark plugs. This one is spark plugs. This is the high tension cables of those spark plugs. This is the igniter. There is this coil, it is the coil of first plug, coil of second plug, and the other one, it have the all spark plug have its individual coil. So this coil or the production of the spark on this electrode of spark is controlled by this ECU or electronic control module. So this coil, it's controlled individually by this electronic control module. So we receive the functions of this fuel system. It is used in the engines, turbo engines, to produce the spark, especially on the petrol engine, to produce the spark in order to burn air and fuel mixture inside the cylinder, engine cylinder. That explode of that mixture, because of the ignition or ignite of the high strong sparks of this spark plug, it will cause explosion of that mixture that cause the force to push the piston downward. That force that push the piston downward, the crankshaft, it converted into rotary motions. That rotary motions, it transmits from the engine to the clutch to the transmission lines of the engine in order to turn the wheels through the propeller shaft, differential, axle, until to the final drive or wheels in order to the vehicle. So there is other system called the fuel supply system. The fuel supply system, it have the different components. The first one, it is the fuel tank or fuel reservoir. The function of this fuel reservoir is to store the fuel. So there is the fuel pump, electric fuel pump. Its action, or it's to put the fuel inside this fuel tank and deliver it to that common relay. We see here there is a pipe, fuel pipe, or fuel hoses. Also there is the return one. There is other one which is connected to that fuel pump, electric fuel pump, which used to carry the pressurized fuel to that common relay. This common relay, it is used to receive that fuel. So there is the pressure regulator. It is just used to regulate the pressure inside this common relay. If the pressure exceeds, it just it's operated. There is the diaphragm. If the pressure exceeds, it pushes the diaphragm and it spring, then open the passage of this return, and that excess fuel is returned back to fuel tank or fuel exit fuel to reservoir. So there is also return fuel from this common relay. When it exceeds, also it returns back to the fuel tank. So this is the injector. It is just used to inject the fuel, to inject the pressurized fuel in the cylinder. So in order that air and fuel mixture to be pressurized and to be optimized, it must be injected the fuel on the certain pressure in order to mix with the air rapidly. So after that, the piston, it compresses that air and fuel mixture on the certain level of the compression. The ECU, it controls it. We will see how it controls it. So in order to produce explosion inside the cylinder and force the piston down, that linear motions of from top to down the crankshaft through the connecting rods of pistons, transmitted that force or that linear force of motions, and the crankshaft turn it into rotary motions in order to drive the transmission line. So after the fuel, there is other one. So as we told that before, this is computer. It just control each injector individually. It control if the compressions, if the first cylinder, it is supposed like a cylinder, engine cylinder. So if this computer from different sensors and its information they provide. It is said that the first cylinder, it is near top deep center, it needs a spark to burn the air fuel mixture. It is controlled by ECU. Also this injector is controlled by this ECU individually in order to open or to close the injections of these injectors. So there is other systems which is essential. There is air induction system. Yeah, first component is the air mass flow sensor. So it is used just to measure the amount of air from the atmosphere entering in the air induction systems. So the air must be appropriately measured in order this ECU provide the fuel according to the air or amount of air entering in the cylinder. This is the suppose as the engine cylinder. So when you are driving at the higher slope, it means that you accelerate higher. So it means that the air entering in the air induction system, it will be higher. So this ECU, it just detected that physical conditions through that information. The air mass flow sensor provide to the ECU and command that injector it must inject the more fuel according to the air entering in the cylinders. So there it is the sensor. So this is the throttle body. There is the throttle position sensor. There is the servomotor. This sensor, it just senses the position of the throttle valve inside this throttle body and provide that information to that ECU. So in order ECU decide or command the servo motor to open the throttle valve inside this throttle body, it open high. If it open high, it means that the air entering in the cylinder, it will be also more quantity or more amount of the air. So if it is it's just closed or open slowly, it means the air entering in the cylinder, it is the fuel according to the condition where you drive your car. If it is the high slope or down slope or straight roads, that information it is provided by different sensors, and the ECU command this throttle body to open according to the condition you're driving. So it is just connected to that air mass meter flow sensor. So it just work together in the air induction systems. There is also another thing called the idle speed actuator. So it is just used to allow the few amount of air entering in the cylinder while you are not accelerating your vehicle. It's in order to prevent the engine shut off, we need a few amount of the air entering in the cylinder in order to keep the engine running. I think that is the components according to the air induction systems. There is also another one. This is the different sensors according to the different systems. So this is the oxygen sensor. This oxygen sensor is just used in the air recirculation systems or exhaust air recirculation systems. It is just used to detect if there is any amount of the oxygen present in the exhaust gases. If there is, it means that there is some mixture that is not burned well. So it means that the engines will get the low power because the amount of the explosion provided, it is not enough because there is some mixture that is not burned well. So this is it detected that oxygen and send it exactly that information to that ECU. So if the ECU detected that conditions, it will just command that one called the EGR valve to open the passage that connected the exhaust manifold and intake manifold. You just open it to allow that exhaust gases return back to the intake manifold in order again to return in the cylinder and burn it well. So this is some component used in the exhaust gas recirculations. It's called EGR valve. We see its functions, and also there is there what's called plug valve. This is used to improve the mixture burn fast. So it is just connected to the fuel tank. If there is the vapor of hydrogen, it just pass from that reservoir and pass through there, and there is some levers that absorb the carbon and allow the hydrogen to move in the intake manifold. So the reason why to allow the hydrogen to move in the intake manifold is that when it mixes with the entering air from atmosphere, when it goes in the cylinder, engine cylinder, it will be burned fast and produce the more efficient of the engines. So this is the engine temperature sensor. It is just used to detect the temperature of the engine through the cooling system. It just, because there is the cooling system in the engines, it will just cool the engines, and that information from the water, because the water absorbs that heat, it will just pass through on that head of sensor, and that sensor detected that the engine it reached on that temperature. It sends that information to that electronic control modules. So this is the knock sensor. Knock sensor, it is used to detect the unusual conditions of knock or sound. If engine there is unusual sound, that knock sensor it just detected that, then send that information to that ECU. The ECU it regulates that conditions according to all information from different sensor provides. And also there is camshaft position sensor. It just detects the positions of camshaft. There is another one which work together. There is crankshaft position sensor. Also it detects the position of crankshaft. Turn on acceleration position sensor. This it acts as the accelerator pedal. So if you increase the speed, you see. If you reduce the speed, you see. It means that you're moving on the low speed. It is where the engine is where the idle speed actuator provides its function to allow the little air entering in the cylinder to provide the smooth engine running during when you don't press on accelerator. When you press on accelerator, you see that how the ignition system works and the crankshaft and the positions. So thank you so much.